The joint CDF has some other interesting properties. So the first one is that the joint CDF is a right continuous function of x. This is basically same as one single random variable. If you consider y as a fixed parameter, these joint CDF should have all continuous properties that we have for a single random variable. So this is easy to prove. So it's same as the single random variable, which is basically is that the CDF is always takes the value from the right side. So this guy is equal to, by definition, this guy, it means that limit of fxy of x, let's say plus epsilon and y, and then epsilon tends to 0, but epsilon positive from the right side. So also is a right continuous function of y. Similarly, the proof is easy, so I don't look at it. So this means that at any point, it takes the at any cliff points, because you have two values for x, and then you have another value for y. So at any point, if there is any discontinuity, you take the upper or easterly, northerly value. So it's kind of like, so the marginal CDF. So marginal CDF is that you want to get rid of this one. So you substitute one of them with plus infinity, because you know the xy of x and y basically is probability that x is smaller than or equal x and y is smaller than or equal y. So if I replace this by plus infinity, okay, plus infinity, and then y becomes plus infinity, these events becomes your the whole sample space. So this is like this comma is intersection, so this becomes probability of x is smaller than or equal x, and then you get fx of x. So this is a marginal density. So just what you need to do is to replace y by plus minus infinity, and then you get the marginal density of x. Similarly, you could get the other distribution. So simply, this means that you let y to go to plus infinity, you find a marginal distribution for x. Another reason why we call this marginal distribution for x, because the random variable y disappears here, so it is marginalized. A third reason for marginal distribution, because you have this is x, this is y. Okay, if you go to y plus infinity, if you look at, if let's say this is your eyes, okay, and this is your nose, smiling. If you look at the top, from the top margin, you see the distribution of x. And if you go from this side, and if you look from this side, okay, and nose, don't forget smile. This is the I see fx of x, fy of y, because x is infinity, fy of y, and from the top I see fx of x. From this side I see 0, from this side I see 0. So for marginal CDFs is to eliminate some of them, or look at the margin and look at the sum of them. And we have also this expression.